Hello there, Wildcats. Welcome to your geometry class. In this video, you will be learning about the trigonometric ratios. So the focus standard of this one is SRT 7, wherein we are going to explain and use the relationship between the sine and cosine of complementary angle and also your tangent. Essential question is how can we find the sine, cosine, and the tangent of an acute angle? How do we use trigonometric ratio to solve real-life problem? Now, our objective in this lesson is we are going to define and calculate sine, cosine, and tangent ratios. And then we're going to use this given this said trigonometric ratio to solve problems. Essential understanding, for any two right triangles with a given acute angle, the ratios of any two corresponding side length are equal. The ratio of the opposite side of the hypotenuse is the sine ratio, and the ratio of the adjacent side of the hypotenuse is the cosine ratio. And the ratio of the opposite side and the adjacent side is the tangent ratio. I'm going to introduce to you a simple way to memorize that essential understanding. So in this lesson also, we are going to review proportion and ratio that we already discussed during our similarity discussion. And the new vocabulary that we are going to define in this lesson is cosine, sine, tangent, and trigonometric ratio. Now, there are three trigonometric ratio. Okay. First is we have your sine, abbreviated as SIN. That's not sin. So you still have to say that sine. So the ratio there is sine theta is equal to opposite side over hypotenuse. I'm going to introduce to you the three trigonometric ratio, and how after that we are going to I'm going to teach you how are you going to identify the opposite side and the hypotenuse and the adjacent side. Second is we have your cosine, abbreviated as COS or cos. The ratio here is cosine theta is equal to adjacent side over hypotenuse. And the third one is we have your tangent, abbreviated as tan, or you still have to say it as a tangent. The ratio is tangent theta is equal to opposite side over adjacent. Now you will, if you have noticed here, I always have, I'll just go back there. You will see this one here. I'll just highlight. You'll see this. I always say theta because that is a Greek letter, which is the letter theta. This is the symbol for an unknown angle measure. Its name is theta. We usually use angle A, angle B, angle C, or if it is unknown, then we call it theta. Okay. So the easy way to remember your trig ratio is we have SOHCAHTOA. SOHCAHTOA means sine is equal to opposite over hypotenuse. Cosine is adjacent over hypotenuse. And the T here is tangent is equal to opposite over adjacent. Now I want you to pause this video and I want you to take this down on your notebook because we will be using this one all throughout the process on this lesson. Okay, now let's practice. Let's practice this. So we you have to put in your mind the word SOHCAHTOA. Okay. Okay, let's practice. So if they will tell you in this given here, okay, so in this given, we have to identify the trigonometric ratios that we have here. Let's start with with the A and then the B. We will be focusing on the acute angle of the right triangle. Okay, so let's start with the our reference angle is angle A. So our reference angle is angle A. So let's find sine A. Sine A. We said that it's the word saw, and then cosine ka, and then your tangent is toa. So let's start with sine A. It says there sine A is equal to opposite over hypotenuse. And take a look at your reference angle here. It's this. The opposite side, you are looking at the opposite side, which is A. Therefore, sine A is equal to A over, and then we have H is the hypotenuse. Hypotenuse is the C. So sine A is equal to A over C. How about cosine A? Okay, it says there cosine A is adjacent over hypotenuse. When we say adjacent, it is next to the angle. So adjacent of A is B. Okay, adjacent of A is B. Therefore, cosine A is equal to B over hypotenuse is C. Okay, now let's proceed with tangent A. We said that tangent A is equal to opposite over adjacent. The opposite of A is A, so tangent A is equal to A, and the adjacent of angle A is B. Therefore, tangent A is equal to A over B. Okay, now I'm going to change color of my pen here. So you can see, I'll be using red here. My reference angle is angle B. Okay, that's where I'm going to start there. I'm going to look for sine B. Okay, sine B, this is my B. Sine B, its opposite is B. So it's B over my hypotenuse is C. It's C. Now your cosine B is equal now to cosine is adjacent is A. So adjacent is A over C because adjacent over hypotenuse. And then we also have tangent B that is equivalent to opposite, which is B, over adjacent, which is A. So this is now your the three ratios for each reference angle, angle A and angle B. All right. So that is how we used to do our trigonometric ratio. Now, what if there is the measurement of the sides of the triangle? So what should we do about that? Okay, that will be our next example. But before we go to our next example, I want you to pause this video and copy our example. Okay, next example is this. So we're going to practice what if we have the measurement of CB is 2 and BA is 3. So let's start with your reference angle is A. I'm going to use a different color. So my reference angle is A. So I'm going to find sine A. Sine A is equal to, again, I'll write that. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Now, your sine A, it says they're opposite. Sine A opposite is 2. And then my hypotenuse is, there's none there. So that will be over CA. Okay. And then how about sine B or cosine, sorry. Cosine A. So let's say cosine A, that would be adjacent, which is 3, over hypotenuse, which is CA. Okay. Now, your tangent A is equal to opposite, which is 2, over adjacent, which is 3. So basically, you only have your tangent here as a representation of the 2 over 3. Okay, because your angle is unknown, and then you have your hypotenuse is unknown, so you only you can only look for the measurement of the angle A using tangent. Okay, next is we have to practice some more. It says there, find tangent A. Okay, we have to find tangent A. So our reference angle is A, and we know the tangent in your saw TOA is opposite. We'll be using tangent. It's opposite over adjacent. So opposite is 12. So tangent A is equal to 12 over adjacent side of angle A is 21. Okay. Now, the question there is, can we still simplify 12 over 21? So to simplify our 12 over 21, we can say that tangent A is, maybe you can simplify this one into 4 over 7. So by 3. Okay, it's the same. Now, in second, tangent A reference, that's tangent A. Tangent A is equal to opposite, which is A, and adjacent side, I'm talking about adjacent, it's 4. So tangent A, which is 8 divided by 4, it's 2. Okay. Let's can pause this video, guys, to take a look at our example. Next is how about this, guys? We have to find the value of x. So this is x centimeter. And then we have the measurement of angle here. We can only solve this problems on trig ratio with the help of calculators also. Okay, so we can pull out your calculators, guys. So let's take a look at this one. So I'll write saw TOA. So this is our baseline. So my angle here, it has opposite over the hypotenuse. Mister, how did you know that 15 is the hypotenuse? It is because it's always the opposite of your right angle. Okay, so the opposite side of the right angle will be your hypotenuse. So I have opposite over hypotenuse. It's sine. So I'll be using sine. Instead of putting something in here, it would be the measurement of the angle. And the measurement of the angle is 34 degrees. So sine 34 degrees is equal to opposite, which is x, over your hypotenuse, which is 15. Now we cross multiply this. When we cross multiply, of course, there's 1 here, invisible 1. So you only have x in this side. And then we have sine 34 degrees. And then we multiply this one by 15. Okay, so I'm going to pull out my calculator here, and I'll just put it there so you can see. I'm using dual screen here, so bear with me, guys. All right, so I'll turn this on. Okay, so I'll press my calculator. It's in there. I think you still have this calculator. So it says there sine 34 degrees. So you will see here we have your sine, you have your cosine, your tangent. This is the one that we are looking at right now. So I'll press sine and then I'll put there 34. Oh, wait. So I have to close that. Sine 34 and then double close. So I'm to emphasize it as I'm multiplying it with 15. Oh, sorry about that. Okay, so there's one thing before I'll proceed with that. There's one thing that I have to emphasize. This radian here must be in degree. Okay, that must be on degree. So I'll just go over and change that mode, and then I'll go down. Instead of radian here, I'll have to go degree and then enter so I can get the right answer. So that's in degree right now. So I'll do the process again. I'm sorry about that, guys. Sine 35 or 34, I should say. And then we'll multiply that with 15. And then close, and then you just put enter. Therefore, your x is 8.39 or 8.4. So the value of x here is, sorry, 8.4, right? Okay, 8.4. So x is equal to 8.4 centimeter. Leave it to the calculator, guys. Okay. You can pause this one. You can pause this one to copy this example. Okay. Okay, next. Again, do not forget to put your calculator on degree measure. Right, this one is we have our reference angle is 53 degrees and it has opposite and adjacent. Adjacent is next to each other. So I would say I'm going to use tangent from SOHCAHTOA because SOHCAHTOA it's tangent opposite over adjacent. So tangent 53 is equal now to, we have opposite is x over 12. You cross multiply this one. Of course, there's one here, invisible one, so I only have x is equal to tangent 53 times 12. So what will be the value of x? I'll go back again with my calculator here. So in my calculator, you can see that I'll press close it, then I'll go tangent 53. So tangent 53, double close, and then I have to insert there 12 because I'm multiplying 12 to tangent 53. So you just put enter, that's 15. 15.92. So I'm just being technical there, 15.92. So 15.92 centimeter. You can pause this video again to copy our example. Okay. Next is we have this example. Oh. So, SOHCAHTOA. As what I have said, in identifying the hypotenuse, it's the longest leg. So it's always opposite of the 90 degree. Therefore, this one, it's opposite of 90 degree. It's hypotenuse. So your x is your hypotenuse. And our reference angle here is 68. So 68, it has adjacent. So this is adjacent. This is not always the adjacent, guys. It can be opposite if the reference angle is here. It's opposite. But because our reference angle is 68, this will be adjacent and it has hypotenuse. Adjacent and adjacent and hypotenuse. Adjacent and hypotenuse. So we'll be using cosine. Cosine, or I'll just put there cos. So cosine 68 degrees. 68 degrees is equal to adjacent, which is 18 over x. Okay, so if you will encounter this type of problem, okay, so you'll just exchange it. Okay, exchange your x and cosine 68, because what will happen is 18 times 1 will give you 18 is equal to, because there is an invisible one there under cosine 68, and x times cosine 68, and then again you will go and divide this one by cosine 68 so that this will be cancelled. So we have cosine 68. So we have 18 over cosine 68 is equal to x. So as you can see, in here, we have 18 over x, and then you have the cosine. So instead of doing this process, you have the chance to exchange this one. So it will become x is equal to 18 over cosine 68 immediately if you have this type of problem. So I'll go over and pull out my calculator there. So I'll put a fraction. So second alpha second, and then enter. So I have 18, and then I'll go cosine 68. Again, guys, if you find this this example as fast, you can just pause this video. So 18 over cosine 68, if I'm going to enter that, it will give me 48.05. So the value of x here, the value of x is equal to 48.05. So 48.05 centimeter. Can pause this video, guys, to copy our example. Next, we have, oh, this is a different, because we are not looking for the measurement of a missing side, but we are looking at the measurement of the missing angle. And at this point, I'm going to introduce to you how are you going to get the inverse of trig ratio. Okay, it's the opposite. Let's see. So in this matter, we'll still have to use your SOHCAHTOA, but instead of the tangent, sine, and cosine, we'll be using the inverse of those. Okay, so your theta here, which is the unknown angle, it has your opposite, and then we have your hypotenuse. So opposite and hypotenuse will be SOH, S-O-H, which is sine is equal to sine theta. So I'll just put there sine theta is equal to opposite, which is 22, over hypotenuse. So it would be 42. Now, I'm saying this one, guys, because why are we using the inverse of sine and cosine and tangent, and when are we going to use them? We are going to use those inverse of this trig ratio when you are looking for the missing angle, meaning the unknown in the given is the angle, not the side of the triangle. So what will happen is this one will be transferred on the other side. Now, every time you transfer this trig ratio, of course, it will go over with the equal sign. So it will change. The sign will change. It's like if you have a positive on this side, if you go and jump into over your equal sign, it will become a negative. Okay, if you have positive here, if we'll jump over to the equal sign, every time you jump into the equal sign, will change the sign or the operation. Now, so what will happen when I do that? I will have your, what we call now your arc sign. So this is your theta, and your arc sign would be sine raised to -1 times 22 over 42. So the inverse of sine will be arc sine. The inverse of cosine will be arc cosine. The inverse of tangent will be arc tangent. So we call this one arc. Arc, and then the sine, arc, cosine, arc, tangent. Okay, so Mr. How would I do that in the calculator? So I'll go back with the calculator. There, I'll turn it on. So I'll just clear this out. So when we do your arc sine, press second, because you can see the blue color in your calculator. There is arc sine, arc cosine, and arc tangent on top of it. It's here, it's the blue color. So I'm using the second function. Okay, the green color will be your alpha. So second function here. And then I'll press, I'm using sine, so you will see there. And then I'll go say alpha y equals for my fraction, and then I'll press 1, enter. So my fraction would be 22 over 42, and then I'll close the parentheses. So again, if you need to pause this video and go back on the process of using the calculator, you can do so. Okay, so I'll press enter. Therefore, it's 31.58, so I'll round it off. It would be 32 degrees. Okay, so I'll just put there 31.58 degrees, or the theta is basically 32 degrees. This is 32 degrees. Next problem. Again, it's the same problem. We still have to use SOHCAHTOA. In your reference angle, we have opposite and then adjacent. So I'll be using TOA, opposite and adjacent. So tangent theta is equal to opposite, which is 17 over 22. So I'll transfer my tangent on the other side. So I only have theta, but my tangent will become arctangent, and then 17 over 22. So again, the measurement of the angle, if I'm going to use my calculator right now, there you go. So I'm going to second and then arctangent, and then I'll go alpha y equals for my fraction. I'll get 1 there. My fraction is 17 over 22. And then I'll close that. And then enter. It will give me 37.69 degrees. So it would be 37.69 degrees, or your theta here in simplified form will be 38 degrees. So I'll just put there or. Okay, so those are our trig ratios, and how are we going to solve for the missing side or a missing angle? Don't you know that there are types of angle? It will be basing on the perspective of the viewer of the angle. So these are the two types of angle. One is the angle that your line of sight makes a line drawn horizontally. So it's your line of sight. There is on the horizontal. And then, of course, there is an angle of elevation, and there's an angle of depression. When we say angle of elevation, as you can see here, angle of elevation, This is the angle of elevation here. So this is your line of sight, and this is your horizontal line. Okay, so if you do that, and then the line of sight we have there. And then we also have angle of depression. So your horizontal line, the angle of depression when you go down there, that's the line of sight that you have there. So one of the example of angle of depression is, let's say you're on top of a building and you are looking down. Okay, so the angle of elevation, it's between your line of sight and the horizontal line, right? So I'm going to give you an example of this angle of elevation and angle of depression, or the application of trig ratios. Okay, right, this one. So let's say indirect measurement. So given we have 45 feet and 59, so we are looking for the height of the tree here. So how are we going to do that? So I'll just take a look at my reference angle, which is 59, and it has opposite, and this one is adjacent. So it's tangent. So tangent 59 is equal to opposite, which is the height of the tree, and adjacent will be 45. Okay, so I'll just multiply this two. So height is tangent 59 times the 45. Okay, so height, it would be, I'll go with and check with my calculator here. So I have tangent 59, I'll close that, tangent 59, double close that, times 45. I'm just making sure, guys. So you would say tangent 45. That's why I'm double closing the parentheses. And then we have 74.89. So the height is 74.89, 74.89 feet, or we have the height is 75 feet. So that's the height of the tree. All right, so that's what we used to do with the trig ratio. Again, guys, if you have any problem with trig ratio, I encourage you to join us during our live Zoom meeting. So you can ask me there, or you can email me, or I'm available during Monday to Thursday from 9:15 to 9:45 for a small group support. We'll see you in the next video, guys, and have a good day. Bye-bye, and hope to see you on live Zoom meeting. I encourage you to do so.